The universe is rewriting its own story. And somewhere out there, the next big discovery is waiting for us, something that could change everything we think we know about life itself. It has now been 3 years since the James Webb Space Telescope of NASA was launched to study the early history of the universe. The telescope goes much deeper into the early universe to uncover the secrets of star birth, the death of galaxies, and all secrets lying in between. So, what exactly did it find? Let's start with the Sombrero Galaxy. In visible light, it appears as a stunning, well-defined, hat-shaped structure. But when we view it in mid-infrared, Webb reveals intricate clumps of gas and dust in its outer ring. These clumps are not just random, they could be active regions where stars are being born. The outer parts of the galaxy are generally overlooked in routine observations, but Webb's ability to observe infrared wavelengths will allow us to see deeper into its structure and therefore gain a better view of its dynamics. Next, Webb detected a supermassive black hole situated within a remote dwarf galaxy that is devouring matter at an incredible rate. This black hole is consuming and carrying along with it surrounding material, gas and dust at a speed never measured before. The exciting thing about this find is that it gives a clue as to how black holes might have rapidly grown in the early universe. That's a big mystery for scientists, how these cosmic giants formed so quickly. Webb's observations are helping fill in the gaps in that story to understand how these supermassive black holes came to be. Finally, Webb captured a pair of interacting galaxies, dubbed Penguin and the Egg. This pair is undergoing a gravitational interaction that's distorting their structures. One of them has spiral arms that are so obviously warped that it looks like a penguin holding an egg. Not only is this a striking image, but it also gives a clue as to how galaxies actually interact and merge over time. When galaxies do collide or merely pass very near to each other, their mutual gravity can distort their shapes, kickstart new generations of stars, and even spawn completely new features. Webb's vision of these fateful moments in cosmic drama provides a fresh perspective on the evolution of galaxies and the ways they shape the universe around them. Webb has unveiled for us distant star-forming reaches in breathtaking detail, such as the famous cosmic cliffs in the Carina Nebula. Previously obscured from view by dense clouds, towering pillars of gas and dust are now revealed in stunning detail. Webb's mid-infrared vision cuts through the intervening dust and reveals new stars being born right within these enormous structures. The cosmic cliffs resemble stellar nurseries that show us the birth of new stars right before our eyes. Webb has also opened up the study of exoplanets and their atmospheres. One of the most important things it discovered is the atmosphere of the exoplanet K2-18b. Webb has identified complex molecules like water vapor and methane in its atmosphere, offering clues about the planet's potential to support life. This M-type star is within the habitable zone of its star, which means that the conditions there could be just right for the existence of liquid water. Methane and carbon dioxide were found in the atmosphere of K2-18b, a reasonably close exoplanet that orbits a cold star 120 light-years away from Earth and is bigger than Earth but smaller than the massive planets in our solar system, by the JWST in September. It could be an ocean world, an exoplanet with thick, hydrogen-rich atmospheres and seas of liquid water beneath, according to earlier Hubble Space Telescope findings. That theory is supported by recent JWST measurements, which reveal that methane and carbon dioxide are abundant while ammonia is scarce. These findings are based on only 2 observations, with many more to follow. Another major finding describes Webb's power to view the dim light of galaxies that shone just after the Big Bang occurred. The ability to see such infant galaxies is important in trying to piece together how the early universe looked. Webb will have infrared vision, allowing it a better view deeper into space and back farther in time than any other telescope that has come before it. As scientists study the properties of these early galaxies, They also improved their understanding of how galaxies grew and evolved during the first billion years after the Big Bang. Besides the space findings mentioned above, Webb has also granted us pictures in great detail of some of the most profound space mysteries while discussing the interaction between supermassive black holes and the surrounding environment. Webb's infrared vision captures the incredible energy that emerges from the interaction of matter with black holes as it forms powerful jets and radiation that reaches incredible distances. This information allows astrophysicists to better comprehend the effect of black holes on their respective host galaxies and the universe as a whole. With each breakthrough, we inch closer to answering the big questions. How did the universe begin? Are we alone? And what mysteries still await discovery? The discoveries coming in from the Webb telescope are really pushing the envelope on what happened in the first moments of the universe, opening up new possibilities on how galaxies, stars, and even large cosmic structures came to be. With its powerful infrared vision, Webb can look deep back into time to see the universe in its childhood, studying galaxies and stars that were formed just a few 100 million years after the Big Bang. One of Webb's most surprising discoveries is detecting galaxies from this early era. They are far beyond the reach of any telescope that came before us, and their light took billions of years to reach us. With Webb's infrared vision, we can now look at these galaxies in incredible detail. These images show us the first glimpses of galaxy formation and how galaxies grew and evolved over time. Scientists are learning how the first galaxies began as small, clumpy structures that eventually merged and formed larger, more organized systems. Using Webb's view, it is feasible to investigate the participation of dark matter in the commencement of the universe. Although it has already been a long time that it is known that dark matter is crucial for building galaxies, its material remains a mystery. The research that studies how galaxies were distributed and moving in the early universe will help scientists in determining precisely how such matter influenced the formation of large cosmic structures. Not only does the James Webb Space Telescope have the ability to look at galaxies that are far away, it also provides us a portal through which we can gaze into the period when the first stars were released. The latter are referred to as population 3 stars, which are presumed to have been the first formed stars. Despite the fact that these particular stars have not been observed directly, using Webb's sensitivity to detect faint signals coming from the earliest galaxies, their formation is getting closer to the ultimate understanding. The early stars were actually completely different. They were much more massive and therefore much hotter than the stars we see today, which means their death could have played a role in creating elements from which life evolved. That is why this has been hypothesized. Webb's study of the early universe encompasses not only observing distant galaxies and stars, but also is contributing to the knowledge of the conditions that were in the universe right after the Big Bang. By using research into cosmic microwave background radiation and the blending of old universe chemical compositions with new ones, Webb is presenting a new, clearer vision of the first few 100 million years of the universe to scientists. The results of the first observations are the ground for further study, bringing about a more detailed picture. With each new discovery, we're getting to know just how old our world is and how it has developed to become one of the greatest living spaces for living beings. If you think that that's all the James Webb Telescope has managed to reach into, you're not quite there. Webb's infrared vision is going deeper into planetary atmospheres and studying dynamic weather systems than ever before. Scientists were overjoyed when the James Webb Telescope found an unexpectedly small asteroid in the broad asteroid belt between Mars and Jupiter. This space rock, which is said to be the size of the Washington Monument, is thought to be a remnant from the formation of the solar system and consequently comes with an intriguing tale of how it formed. The discovery highlighted the telescope's utility closer to home, as asteroids smaller than a mile in length are hard to detect with traditional telescopes. One of the most interesting applications of the technology that Webb represents is its study concerning exoplanets, that is, planets that orbit stars that are not part of our solar system. Many of these exoplanets lie in what scientists call the habitable zone, the region around a star where conditions might be just right for life to exist. Webb provides the capability to see weather on these other worlds, to track clouds in motion, changes in temperature, even seasons changing on a planet beyond our solar system. These observations will supply scientists with the necessary details to work out under what conditions exoplanets could be hospitable and what kinds of environments they might host. Within our own solar system, Webb will deliver observations of the outer planets and their moons. Webb has targeted one of the giant gas planets, that is Jupiter. It will give us more detailed knowledge of the composition of clouds, weather systems, and even faint rings within its atmosphere. Already, the telescope has made some striking images of the planet, bringing out the Great Red Spot and other storm systems with incredible clarity. At the same time, the infrared capacity of Webb is helping scientists to look through Jupiter's thick cloud layers. Webb is particularly focusing on analyzing the surfaces of Jupiter's moons, Ganymede, Europa, and Callisto, and their atmospheric conditions. Due to the fact that there are subsurface oceans in these moons, it is rather obvious that they've been deemed viable for life forms. Webb's capability to study their surfaces, as well as their atmospheric conditions, will be beneficial to comprehend the scope of life on these objects. We know that the universe is growing in size, but we are not exactly sure how fast that growth is happening. Now, there is a discussion about what the correct precise figure of the Hubble constant is. As of right now, numbers derived from telescope observations and model estimations for the Hubble constant do not coincide. A type of stars that are called Cepheid variables, which are typically massive stars about 1 million times brighter than the Sun, were seen by the James Webb Telescope this year. However, the evidence from the James Webb Telescope merely served to intensify the current discussion about the Hubble constant rather than to settle it. The buzz about Webb's mission is not just about discovery in science. It is about the future of space exploration and the inspiration it brings to a new generation of thinkers, explorers, and dreamers. With the capability to study the universe at such an incredible level of detail, Webb will grant us previously unattainable visibility into the cosmos, piquing interest and excitement in all that follows its progress. But this is just the beginning. As Webb continues to reveal the hitherto unseen marvels of the universe, the opportunities for fresh perceptions, discoveries, and breakthroughs become virtually boundless, as accessible to the casual stargazer as to the working scientist. So stay with us, stay engaged, because we are just at the beginning of this journey, and who knows what amazing discoveries await us. The universe is out there, and with Webb, we are one giant step closer to revealing its deepest secrets.